In this video, we have given a diagram and it is given that string is massless, but the coefficient of friction between string and pulley is mu, and we have to find the maximum value of m2 by m1 if box remains at rest. So basically, we have a pulley and this is a string, and if the tension at one end of a string is T1 and the pulley is not frictionless, so there will be friction between string and pulley at every point of contact. So suppose the friction is dF at every point of contact, so the tension at other end will be some T2. So due to friction, tension is changing, so we can say that dF is equal to dt, and this is pulley, and if we take a small portion of a string, this is very small portion, so this angle will be d theta, and there will be a normal force perpendicular to the surface. Suppose it is dn, and tension at one end of a string is T, so the tension at other end of a string will be T plus some dt, and this complete angle is d theta, so half angle will be d theta by 2. So this angle also will be d theta by 2, and this angle is also d theta by 2. So we can say that elementary friction dF is equal to mu times dn, and if we balance vertical forces, then we can get dn is equal to t plus dt sin d theta by 2, t plus dt sin d theta by 2 plus t sin d theta by 2, and we get dn is equal to t plus dt. Here dt is much less than t, so t plus dt will be approximately equal to t, so it is t sin d theta by 2 plus t sin d theta by 2, and we get dn is equal to 2t sin d theta by 2, and for a small theta, sin theta is approximately equal to theta, and d theta by 2 is very small, so we can say that sin d theta by 2 is approximately equal to d theta by 2. So we get dn is equal to 2t, and sin d theta by 2 is d theta by 2, and 2 and 2 will get cancelled, and we get dn is equal to t d theta, and we have dF is equal to mu times dn, so we get dF is equal to mu times dn is t d theta, and dF is equal to dt, that is equal to mu times t d theta, and we can get dt by t is equal to mu times d theta. And if we integrate both sides, then t is changing from t1 to t2 and theta is changing from 0 to pi. Here theta is changing from 0 to pi. So integration of dt by t is ln t and t1 to t2 is equal to mu is constant and integration of d theta is theta 0 to pi, and we get ln t2 minus ln t1 is equal to mu times pi minus 0, and it is ln t2 by t1 is equal to mu pi, and it is t2 by t1 is equal to e power mu pi, or we get t2 is equal to t1 times e power mu pi. So this is the pulley, and here mass is m2 and here mass is m1. So the force will be m1g and upward force is t1, and here downward force is m2g and upward force is t2. And since it is balanced, then we can say that t1 is equal to m1g and t2 is equal to m2g. So we can say that m2 by m1 is equal to t2 by t1, that is equal to e power mu pi. So it is the answer.